In today's video, we're going to be solving a variety of integral from easy to complicated integral in just 10 minutes. Are you ready for that? Let's solve it. Let's start with the easy integral. You have integral of 2x squared. How are we going to integrate this? Using the power rule, that will be integral of what? 2x cubed all over 3. Integrating this, what you're going to do first is to multiply this times this. You're going to have 2x to the power 4, and the integral will be what? 2x to the power 5 on 5. Okay, integrating this, so the one, you're going to separate integral on both sides. And that will be integral of what? X cubed all over 3 plus kx, since k is a constant. Integrating this, we do the same thing. That will be integral of x cubed all over 3 plus 20x squared all over 2, plus kx. Proceeding with this integral, moving to complicated integral, we have the integral of x plus 1 all over 1 plus 2x. How are we going to integrate this? That's the question we're asking. In just a few minutes, we use the substitution u is equals to 1 plus 2x as in the equation. If you differentiate this, okay, moving on, u square will be 1 plus 2x. Differentiating that, we're going to have 2u equals to 2gx, 2u is equals to 2gx. Proceeding, we know that x is equals to what? U square minus 1. X is equals to u square minus 1 from here. You can divert x is equals to u square minus 1 because at the point we're going to substitute it here. Okay, substituting back everything, we're going to be having what? Substitute, you're going to have u square minus 1 all over 2 plus 1. Okay, we know that square root of this is equals to u. That is why we substitute. Okay, simplifying this, we are going to be having what? U square plus 1 all over u, and this will cancel. You are left with u square plus 1. And integrating this, you are going to have what? U cubed on 3 plus u plus a constant k. Since it's in terms of u, we have to come back in terms of x. Substituting back u here, you are going to have this as the answer. Is that amazing? Yeah. Proceeding with this, integral of 3x all over 4 minus 3x. How are you going to integrate this? We proceed by having the substitution for 3 times x is equal to 2 sine a. That is substitution you give in the equation. Okay, differentiating this, we are going to have what? Root 3 gx is equal to 2 cos a, which implies gx is equal to that. Okay, but x is equal to, you can find x from here. It's 2 sine a over root 3. And we proceed, and if we take root 3x squared, that is, we have to substitute here. We have that therefore 3x squared by this is equal to 2 sine square a. Okay, proceeding, we substitute everything in this equation, and we are going to be having this as the final point. We have a dA. Proceeding with the integration, we move on to this. By simplification, we simplify this to have this. I know you are at this point asking a question: how does 4 minus 2 sine square a move to 2 cos square a? Let's dive into it together. We have 4 minus 2 sine square a from here is equals to what? We bring out this 4. That will be 4 into 1 minus sine square a. Okay, which is equals to what? From half angle identity, we can, this 4 can be like 2 into half times 1 minus sine square a. You're going to be having 2 cos a. That is the answer to this. Are you happy with this? I think, yeah. Proceeding, substitute then this 2 cos a back here, and you're having negative 2. And if you integrate this, you are going to have what? Negative 2 cos a plus k. Because integrating sine a from the square, we come back to minus cos a, and have this as the answer. Moving on to this integral, x squared plus 1 all over x minus 1 squared times x plus 1 gx. Let's look at the timer. We just use 4 minutes. Let's solve this one. Integrating this, we are first of all going to express this into partial fraction. Okay, into partial fraction, we're going to be having x squared plus 1 all over x minus 1 square all over x plus 1 square. In partial fraction, if you take a all over x plus minus 1 plus b all over x minus 1 square plus c all over x plus 1, that is a formula of partial fraction. For simplifying, we are going to be having what? This returns back to integral of this and this. Now we are going to integrate. To integrate this, all what you're going to do is to include an integral sign all over. Okay, and doing that, you are going to be having this1. And integrating this, normally that will be equal to what? Ln x, since it is with power 1, ln x will be included here. And here we are going to use a normal integration rule, that is x plus 1, or that should be -2. Taking this to be u, we are going to be having 1 over x plus 1 as the final answer. Integrating that, you are going to have what? Ln x plus 1 plus half ln x minus 1 minus this plus k. Okay. So, okay, we have a half here, don't forget. If we have ln that, that's our final answer. Moving on to the next question, we have 1 all over 5 plus 5 cos x. Using the substitution, g is equal to tan x plus 2. Differentiating this, if you differentiate tan x on 2, you are going to have half sec square x on 2. How do you know about differentiation? But in earlier trigonometry, 3 ratios, we know that cos x in terms of tan is cos x is equal to 1 minus g square all over 1 plus g square. So we know about that. Yeah, I guess you know about that. Okay, we proceed. You can prove this in another video. I'll just drop this video here proving this. Okay, proceeding. If you differentiate this up here, you are going to have a 2g all over z square. Okay, moving back to gx, because we have to substitute it here. Gx is equal to 2gt all over 1 plus g square. Since sec square, the square theta is equal to 1 plus tan square. And we are in terms of theta is equal to x on 2. Therefore, this is equal to t. That's why you have t square. And that is cos. And you have to substitute back everything here. Substituting it here. We're going to be having what? Integral of this is equal to what? We bring out this 5, 1/5 into 1 all over 1 plus substitute cos dot 2g all over that. And we further simplify to be having this. And if you simplify well, you're going to be coming back with 1, because this and this will cancel. This and this will cancel. Here we are going to be having 2, okay? And at the level of the numerator, we have 2, and 2 will cancel. We are left with 1. That will be 1/5 into 1 dt. And integrating this, that will be 1/5 t. And t is what? Tan x on 2. And that will include a constant k. Solving this other integral, looking at this, how are we going to solve it? We know that x squared minus 4 is equal to 0. How can we do it? We express into partial fraction where x squared is equal to plus minus 2. For x minus 2 and x plus 2 are the factors. Expressing into partial fraction, we are going to be having what? A all over x minus 2 plus b all over x plus 2. So as to simplify this, further simplifying, doing x minus 2, the LCM, by x plus 2 times, we do that is x plus 2 a plus x minus 2, sorry, x minus 2b, you just solve it together, x minus 2b. We are going to be having ax plus 2a plus bx minus 2b. And we equate all this equals to 1. Drawing the like term, a plus b is equals to 0, and 2a minus b minus 2b is equals to 0. Then a plus b and a minus b is equals to 0. And if further simplify, I'm going to have this final value of a and the value of b. And I have this as the answer. Okay, therefore integral of this will be equal to what? Integral of this. And this, what we're going to do next is to include an integral sign all over. Okay, including an integral sign, you're going to have integral of, and integrating, you're going to have ln of x minus 2 minus ln of x plus 2. We keep the square bracket. Okay, from law of indices, ln a minus ln b is equals to ln a all over b. We're having this as our final answer. And we come to the end of this amazing video. We just solve it in less than 10 minutes, that is 9:50 seconds. And you're happy. See you in the next video. Don't quit without watching this other video. Bye.